Welcome! In this video, we'll solve an inverse trigonometric problem. We are asked, if pi over 2 is less than or equal to x, which is less than or equal to 3 pi over 4, then what is the value of the inverse cosine of 12 over 13 times cosine x plus 5 over 13 times sine x? Our goal is to simplify the expression inside the inverse cosine. Notice that the argument, 12 over 13 times cosine x plus 5 over 13 times sine x, is in the form a cosine x plus b sine x. We want to transform this into the form our cosine of x minus alpha, or our cosine of alpha minus x. This will allow us to use the property of inverse cosine. Let's compare the argument to our cosine of x minus alpha, which expands to our cosine x cosine alpha plus our sine x sine alpha. By comparing coefficients, we can set 12 over 13 equal to our cosine alpha and 5 over 13 equal to our sine alpha. To find r, we square both equations and add them together. Our squared cosine squared alpha plus our squared sine squared alpha equals 12 over 13 squared plus 5 over 13 squared. Factoring out our squared, we get our squared times cosine squared alpha plus sine squared alpha, which is our squared times 1. This equals 144 over 169 plus 25 over 169, which is 169 over 169, or 1. Since our squared equals 1, and r is typically positive, r equals 1. Now that we know r equals 1, our equations simplify to cosine alpha equals 12 over 13, and sine alpha equals 5 over 13. We can find alpha using the tangent function. Tangent alpha equals sine alpha over cosine alpha, which is 5 over 13, divided by 12 over 13, simplifying to 5 over 12. We can visualize this with a right triangle where the side opposite alpha is 5, the adjacent side is 12, and the hypotenuse is 13. Thus, alpha is the angle whose tangent is 5 over 12, or alpha equals inverse tangent of 5 over 12. Since sine and cosine are both positive, alpha is in the first quadrant. Now we substitute this back into our original expression. The argument becomes cosine alpha cosine, x plus sine alpha sine x. Using the cosine difference identity, this is equal to cosine of x minus alpha. So our expression simplifies to inverse cosine of x minus alpha. We know that inverse cosine of cosine theta equals theta, but only if theta is in the principal range from 0 to pi. Let's check if our angle x minus alpha lies within this range. We are given that x is between pi over 2 and 3 pi over 4, and we found that alpha equals inverse tangent of 5 over 12. Since tangent of 0 is 0 and tangent of pi over 4 is 1, and 5 over 12 is between 0 and 1, alpha must be between 0 and pi over 4. Now let's find the range for x minus alpha. The minimum value is pi over 2 minus alpha. Since alpha is less than pi over 4, pi over 2 minus alpha is greater than pi over 4. The maximum value is 3 pi over 4 minus alpha. Since alpha is greater than 0, 3 pi over 4 minus alpha is less than 3 pi over 4. So, x minus alpha lies between pi over 4 and 3 pi over 4. This range, pi over 4, 3 pi over 4, is entirely within the principal range 0, pi. Therefore, since x minus alpha is in the principal range, inverse cosine of x minus alpha simplifies directly to x minus alpha. Substituting back the value of alpha, the final answer is x minus inverse tangent of 5 over 12. This matches option 3. Thank you for watching.